Hello everyone, I'm Stephanie Datillo, a graduate student at Rutgers, and I will be presenting to you my mouse breeder program for the Python Methodologies final. So as a graduate student in the Endocrinology and Animal Biosciences program, I am tasked with maintaining a mouse colony so that I could ultimately use these mice in my own thesis research. So I'll talk to you a little bit about what we have to do to maintain the mouse colony and what this program would add to that. So for basic mouse colony maintenance, it includes things like ensuring the mice are fed and have enough water, as well as proper enrichment. We also check on the mice daily to ensure that everyone is safe and accounted for. We have a lot of important dates that we have to keep track of. When a mouse is born, from that day on, we need to schedule when we will sex the mice, when we will ear notch them, and when we will wean them. As mice deliver their pups on different days, these days become a little bit hectic to keep track of, as well as some other tasks that we have to take care of, such as ensuring we have enough supplies stocked in the room, ensuring that we have a clean room, and ultimately consolidating cages to keep our costs down. But what I find to be one of the most tasking jobs in this is actually breeding the mice and ensuring that we have good breeder pairs. So many different labs have different qualifications for breeder pairs, but I will be talking to you about the qualifications that my lab uses. So to start, mice reach sexual maturity at 8 weeks old, and at 8 weeks old, they are then able to be paired up to breed. The breeding, we like to keep between 8 and 16 weeks because that is the best chance that they will be a viable breeder pair. After 16 weeks old, we don't like to set them up for the first time. As well as age, we also have to consider weight. We don't want mice to be set up when they do not weigh enough, because that can also impact sexual maturity. So we want to ensure that our males are at least 25 grams and our females are at least 21 grams. Another consideration that we have to take into account is that you want the males and females to have a body weight discrepancy, but we like to keep it more than 4 grams. It's okay if it's a little bit more than that, but we don't want a difference to be of like 10 grams because that could be too much of a shift in power in the breeding pair. So the purpose of this program that I've designed is to help labs actually set up their breeder pairs and keep track of them. So this program will take their Excel files, which people typically use to manage their colonies, and it will output a list of viable breeder pairs for them, as well as adding in new mice as your colony continues to grow. So now we'll take a look at the data file that I'll be using. You can see that there's many columns here, including strain, sex, age, date of birth, mouse ID, genotype, date of death, and a rodent. The rodent can either be a mouse or rat. This file is adapted from the actual mice that I have in our lab. Though we do not have 10,000 mice, so I did add more mice and rats to it as well. So now we can get into the actual mouse library that I've made. We have 2 constants listed here first, and those are 56 and 112. Those are the minimum and maximum age that our mice are going to be when we set them up. We have to put them in as days because that is what our Excel file has. The function that we have listed here is the eligible pair breeder or body weight function, where we take in 2 variables, male body weight and female body weight, and we are trying to see if they will be compatible mice. So we use an if-else statement to look at if male body weight minus female body weight is greater than or equal to 4, that is acceptable. We also want, as I've said before, the female body weight to be greater than 21 and the male body weight to be greater than 25. So if all of those qualifications are met, we will be told that the pairing meets breeder weight minimums and difference in body weight standards. And if it's not, it will say that it does not meet those qualifications. I'll be using these constant later to demonstrate the use of this function. And then we have the animal class, where we describe all the methods of getters and setters to pertain to our attributes for our mice. We have the strain, the sex, the age, date of birth, ID, genotype, and date of death, as well as rodent. This matches the Excel file. And like I said, we have our getters and setters for each of those. And then we also have a method called gestation down here that we pass to the subclass of mice or rats. And this will print out that gestation is either 21 or 22 days, depending on the type of rodent, which is very important when monitoring breeder pairs. So once we move on to our main program, we can see that I am using pandas to import the Excel file because this came so heavily recommended by other Python users. So we could start by running this and seeing that it runs. It doesn't output anything, but it runs smoothly. And we always just want to make a check to ensure that it's actually working. So I'm just going to print the head and tail of this document to ensure that they were actually transferred. So as we can see here, we have both the head and the tail, which is 10,013 mice or rats. So the next step that we want to do is import the class, the functions, and the constants for our program. And we were also going to comment out these so that we don't have them printed every time. And again, we won't actually see anything that comes up when we import them. We will have to actually use the functions or constants or classes to actually see if they're working. So the next thing that I want to do is take this mouse data from the Excel file and be able to convert it to instances in the animal class. In order to do this, I set up this code that converts it to instances and then adds it to a list. So here we can run that. And then again, we'd want to see if it's working. So I am just going to index the list and look at the last 5 animals. And there they are. We can make this a little bigger. And we can see that the list was successful. So then the next step we will be performing is we want to iterate over this list to actually pick out the mice that we want. The first thing that I'm going to pick out is the male mouse breeders. And as you can see, we want to specifically pick them out based on sex, date of death, their age, and that they're mouse. So we can comment this out so we don't have to see that again. And like I said, we will add them to the list. We'll append the list of male mouse breeders if they're males, if their date of death is null, meaning that they're alive, and if their age requirements are met using our min age and max age constants. So we will do that. And again, nothing appears, but we always want to check. So I will run a loop that will ultimately print out what male mice are put into that list, and then print the length of the list as well. It's quite a long list of male mice, so just sit tight for a moment. So 84 male mice that are viable breeders. We can comment all of this out so that we don't have it printed again. And we'll move on. So the other thing I wanted to do is take this list and put it into a queue so that we can store it, and we'll be able to add to the queue So I will add them in, and again, nothing will show, but we will verify this by printing the queue and printing the length of a queue to see that the lengths match. So again, we have a long list to go through, but we'll get there. And again, we have 184. We can see that their IDs are not the same, so we are not repeating the same mice over and over again. They're all unique mice. So next, I want to show you actually adding a mouse to the queue. I've already typed up this new male mouse, including all of the parameters that are needed to be added, and named it new mouse 1 so we can easily pick it out. So let's add it to the list and the queue. And we will also print out the new mouse and the length. So here we actually printed the new mouse gestation, which I wanted to show that it will print out that the mouse gestation is 21 days. Obviously, the male mice are not carrying the pups, but it's still important to know and a good reference. We also printed out their date of birth and ID. And then now that we look at the length of the male mouse breeder's queue, we can see that it is now 185 compared to 184, which means our mouse was successfully added. So quite possibly the most important part of all this is actually having the data somewhere that will be useful. And that is going to be via a TXT file that we will write with all the male mouse breeders. So we can export that and then look into my final project folder where I see the viable male mouse breeders text, which includes all of my viable male mouse breeders. And I like to look at, again, the mouse IDs to see that there's unique mice being added and it's not the same mouse. And then when we scroll all the way to the bottom, we can see that this new mouse 1 has successfully been added to the queue. So now we can move on and we will do the same exact thing for the female mice. We want to look for female mice that are alive and again in between the min and max ages and our mice. And we will add those to a list as well and print out the list and print out the length. It's not necessary to print out the list every single time, but I like to print it out so that I can actually see again that these are different mice and they're not just the same mouse being repeated. So we could comment this out. And we see that the length is 79 mice. And now we are also going to convert it to a queue, and I'll just skip down here and print out the queue and print out the length of the queue. Again, 79 mice, which is perfect. And again, I'd like to show that we are adding new mice to the queue. Let's comment these out. And that this new mouse is successfully added because we went from 79 to 80. And again, we need to export this information so that labs are able to easily access it. And we can go back and find this viable female mouse breeders text, which has all the viable females. And again, we have our new mouse 2 right here on the bottom. So now that we've successfully exported those, I finally just want to show you this eligible breeder pair function working. I can't actually see it on my screen right now, but I will show you that we have used the male 1 and female 1 body weights to compare, as well as the male 2 and female 2, and then I swapped them so that we could compare all of them. So as we can see, by referencing our actual mice, we see that male 1 and female 1 are not compatible because female 1 has not met the body weight requirement. When comparing male 2 and female 2, their difference is not large enough to be considered a breeder pair. But male 1 and female 1 are compatible. We would just then want to think about if there's a maximum difference taken into consideration. And as well, male 2 and female 1 are not compatible because, again, that female 1 does not reach body weight requirements. So that is the entirety of my program. I'd like to bring you back to this PowerPoint slide where we can look at and think about future directions of the program. Like I've said before, there's a lot of different things that labs keep track of with their mouse colonies. Some people track the generations. If you have a lot of mice, then maybe you'd want to add in the cage ID. And at least when you go to pair them up, you'll know exactly where the mouse is. Like I said, you can add in a maximum body weight requirement or body weight difference. But there's a lot of ways that this can be edited. As well, we can also add in rats because we have inheritance set up within our animal class. So if you're a lab that has both mice and rats, it's compatible with that as well. Another future direction that would be great for this is to actually have the computer pair mice together for you. So you just have an output of a male and a female that could potentially be paired. I think that would be very useful in the future, and you don't have to thumb through potentially 184 different mice. But that is all from my program. Thank you for listening, and happy end of the semester.